Imagine sitting in your car, but you're not driving. The steering wheel moves by itself. The car changes lanes, avoids obstacles, and even parks perfectly, all without your hands touching a thing. This isn't science fiction anymore. From Tesla's autopilot to Waymo's robotaxis, artificial intelligence is literally taking the wheel. But how do these cars actually think? How does AI see the world, make decisions, and drive us safely from one place to another? Today, we're breaking down how Tesla, Waymo, and other companies are using AI to transform the future of driving. Before we dive in, let's make one thing clear. When we talk about AI in cars, we're not talking about voice assistants or parking sensors. We're talking about artificial intelligence acting as the brain of the car, the system that perceives the world, makes decisions, and controls movement in real time. It's what allows cars to recognize traffic lights, detect pedestrians, and predict the behavior of other vehicles, all within a fraction of a second. So, let's see how the biggest players, Tesla, Waymo, and others, are pushing the limits of what's possible. Let's start with the name everyone knows: Tesla. Tesla's system, called autopilot, or in its advanced version, full self-driving, FSD, is built on one core idea: vision is all you need. Unlike most other companies, Tesla doesn't use LiDAR, which is a laser-based sensor that maps the environment. Instead, Tesla relies purely on cameras, AI, and neural networks, just like human eyes and a brain. RAS, giving it a full 360-degree view. These cameras constantly feed video data into Tesla's onboard computer. The AI system processes those images, recognizing objects like cars, signs, lanes, and even potholes. But the real magic happens in Tesla's neural networks, computer systems modeled after the human brain. They've been trained on millions of real-world driving videos. And because Tesla has over 5 million cars on the road, every single one of them acts as a data collector. Each time a Tesla drives, even with a human behind the wheel, it sends driving data back to Tesla's servers. The AI learns from every mistake, every sudden brake, every unusual road condition. This is what Elon Musk calls shadow mode. The AI watches silently while humans drive, learning how it should have reacted in that situation. Over time, Tesla uses this ocean of data to improve its self-driving model. When the new model is ready, Tesla pushes it as an over-the-air update, meaning your car literally gets smarter overnight. It's like upgrading your brain while you sleep. But Tesla's approach has one big challenge. Because it relies on vision only, the system must be extremely good at understanding visuals in all conditions: fog, rain, snow, or glare, and that's where Waymo takes a completely different path. Now, let's move to Waymo, a company owned by Alphabet, Google's parent company. Waymo's vision of AI driving is more cautious and heavily data-driven. Unlike Tesla, Waymo doesn't trust cameras alone. Their vehicles use a fusion of sensors: LiDAR, which sends out laser pulses to map the environment in 3D, radar to detect objects and their speed, and cameras for color and texture recognition. Together, these create a 360-degree super sight around the car. Waymo's AI then takes this information and builds a real-time 3D model of everything nearby: vehicles, cyclists, pedestrians, even traffic cones. But Waymo's system doesn't just see what's happening, it predicts what will happen next. It forecasts how nearby cars or people are likely to move in the next few seconds and plans accordingly. For example, if a cyclist is approaching from behind, the car's AI already knows whether that cyclist might turn or stop, and adjusts its path proactively. Waymo's technology is so advanced that in some U.S. cities, like Phoenix and San Francisco, their robotaxis operate completely driverless. No steering wheel, no pedals, no safety driver. You open the Waymo app, call a car, and it arrives, empty. ready to drive you anywhere. It's not the future. It's happening right now. However, Waymo's method also has drawbacks. All those sensors make the system expensive and data-heavy. LiDAR alone can cost thousands of dollars per car. But what Waymo gains is safety and precision. Their cars rarely rely on uncertain visual guesses. In short, Tesla is teaching cars to see like humans, while Waymo is teaching cars to measure like machines. While Tesla and Waymo often steal the headlines, they're not alone in this race. Mercedes-Benz has developed a system called Drive Pilot, officially certified as Level 3 autonomous driving in Germany and parts of the US. That means under specific conditions, you can take your hands off the wheel, legally, and the car handles everything from acceleration to braking. Then there's Cruise, owned by General Motors. Cruise operates driverless taxis in several US cities. Their AI uses both real-world and simulated training, running millions of hours of virtual driving every week to improve safety. NVIDIA, the company famous for its graphics cards, is also a major player. Their Drive, PX, and Orin chips power the AI brains behind many self-driving systems, from Volvo to Toyota. And in the background, Apple has been quietly experimenting with its secretive Project Titan, an electric, partially autonomous car that's still under wraps. Even China is catching up fast, with companies like Baidu's Apollo and Xpeng using deep learning to build their own AI-driven cars. This competition is global, and it's heating up fast. But let's pause for a moment, because while the technology looks amazing, the road to full autonomy isn't smooth. Challenge number 1. The unpredictability of humans. AI can detect obstacles, but it struggles to interpret human intent. For instance, a pedestrian might look like they're about to cross, but then suddenly stop. Humans can read that body language. AI, not always. Challenge number 2. Edge cases. Self-driving systems are great at handling normal traffic. But what happens when something truly unusual occurs, like a mattress falling off a truck or an unmarked construction zone? AI often fails in these rare but real events. Challenge number 3. Regulations and accountability. If a self-driving car crashes, who's responsible? The company? The driver? The AI developer? This question is still legally gray in most countries. Challenge number 4. Public trust. Tesla's autopilot has faced multiple investigations after accidents. Even though statistically it may reduce crashes, one mistake caught on camera can shake public confidence worldwide. Building trust will take time and billions of safe, uneventful miles. Despite the hurdles, the future looks unstoppable. AI isn't just going to make cars drive themselves, it's going to make roads smarter. Soon, vehicles might communicate directly with each other, known as V2V communication, vehicle to vehicle. Imagine your car automatically slowing down because another car, 5 vehicles ahead, just hit the brakes. Add to that V2X technology, where cars talk to traffic lights, road signs, and even pedestrians' smartphones. It's a world where traffic jams are predicted before they happen, and accidents become nearly impossible. Over the next decade, we'll likely see AI managing fleets of autonomous delivery vans, self-driving trucks moving goods overnight, and even personal AI assistants planning the fastest, safest route in real time. We may still be years away from full autonomy everywhere, but the direction is clear. AI will change how we move, how we design cities, and how we think about driving itself. As Elon Musk said, a car is basically a robot on wheels, and it's only going to get smarter. So, the question isn't if AI will take over driving, it's when. Will Tesla's Vision First model dominate the roads? Will Waymo's ultra-precise LiDAR cars become the global standard? Or will a completely new player surprise us all? Let me know what you think. Who's leading the race toward the future of driving?